Speaking from the biochemistry, here you have to identify the type of inhibition shown in the graph. So the graph is given, and out of which you have to select like given graph is from like which name or it is which kind of inhibition. So as I think that you should know that what are the type of the inhibition and where we study about this thing. Actually, this topic is a contraindications. Like actually, this has an explanation in the pharmacology and also in the biochemistry. So before going through this question, I want to tell you that this is a topic comes under enzyme kinetics. Now in enzyme kinetics, what happened that what is enzymes? Enzymes are the basically the chemistry is the catalyst, biological catalyst, which they do not involve in the reaction, but they accelerate or they speed up the reaction. To make it like more clear, like if there is a substrate A plus B which is forming P plus Q, this is the product. Okay, so here some sort of like there is a rate or we can see that the formation of the product. Okay, so there is a rate or the speed of formation of the product. So here under this like column we have the enzyme, and there is a substrate which is being converted into the product. And what are the enzymes? Enzymes act as a biocatalyst. So you can see it is a biocatalyst. What it do? It increase the speed of reaction, or you can say the rate of reaction. So in the enzyme kinetics, like it was like very like what are those things like you are mentioning something a biological compound which is directly giving a kind of like there is interacting with the speed of reaction. So here what happens that in the given question it is asking about the inhibition. Inhibition means first of all when something like this enzyme is acting, and because of that it is increasing the speed. Now there is some sort of inhibition. Okay, so now inhibition can be basically two types. The first one, it can be competitive or it can be non-competitive. So the first one, it can be competitive inhibition, or the next one is non-competitive. In case of competitive inhibitors, what happened that there is a directly substrate is chemically similar to the inhibitor. Now they are the chemically similar. So what happened that substrate is forming a product. Okay, now there is some sort of catalyst or enzyme. Suppose that it is X. X has a specificity to bind with the substrate, but you mix some sort of inhibitor. That inhibitor is like almost similar, okay, to the substrate. So that now what will happen, this inhibitor will interact with the enzyme and the product formation will not take place because there is a directly, it is a competitive. So you are decreasing, or you can, there is a substrate, there is a possibility that those compound, those inhibitors which you will add, it will bind up with the given enzyme and form the reaction. So what happened basically in case of competitive inhibitor actually it is inhibitor, it bind to the active site. Now active site is a like I hope you remember, like active site is a site where from which enzyme bind and they form the product. Now here inhibitors, they basically bind with the active site, and because of that the product formation do not take place. Inhibitors does not change the shape of the active site, so they bind with the active site but they do not change. Inhibitor do not change shape of active site. Now increase in the substrate concentration reduce the inhibition. Why? Because if they are the chemically similar, now what you did that you are increasing the like substrate concentration. If substrate concentration increase, so obviously the substrate amount, the more amount of substrate will be available to interact and to perform the reaction. So there is a possibility you can you can reduce the inhibition. So one more column is there which is V max is remain constant. This I will tell you just within like 1 minute, like within after five minutes. But here Km increases. Okay, these 2 points I will discuss you soon. Now in case of non-competitive inhibition, so here substrate and inhibitor, they are not, like it is chemically similar, so they are not chemically similar, so they are chemically different. Okay, now what will happen if they are the chemically different? So inhibitors bind away from the active site. So where the inhibitor form? Inhibitor bind. So inhibitor, it bind to the allosteric site. So it is not binding with the active site, which is useful for the enzyme. Now in this situation, what happened? Allosteric site is something different. Like if it is an enzyme, and it has this one is the active site. So those things which will bind with the active site, this part, this is the here, this is the basically this is the competitive inhibitor. But in case of non-competitive inhibition, they will find that an inhibitor will bind to the allosteric site. So suppose that this is allosteric site. Now because they will bind with the allosteric site, they what they do, they change the structure of the substrate. Now because of that, what will happen that this structure, okay, because of that there is a structural change. So change in shape of the active site will occur. Okay, so here allosteric site, and there is a change in active site will occur. Now increase in substrate, if change in active site will occur, so there if you because chemically inhibitor and substrate, they are different. So even if you increase the substrate amount, so which it is not going to affect the rate of reaction or the reaction. So that substrate concentration, even if you increase, it is independent to the rate. Now after that, the last one is here, last point here, that Km, it remain constant, but Vmax, it decreases in case of non-competitive inhibitor. Now going through given this graph is actually, it is a Lineweaver-Burke plot, and I'm coming what is the Lineweaver-Burke plot. So to understand this graph, actually here I told you the inhibition concept. Now to go in like the basic thing when substrate react to form a product, so there is some sort of rate. Okay, now what will happen, that rate of a reaction, or you can say the speed of formation of the product. Okay, so here you can say speed of formation of product, or you can say speed of consumption of substrate. Now these two, like a basic concept here. Now when we talk about the equilibrium, so in equilibrium there is R1 is equal to R2, like PQ act as a substrate and AB act as that point as a product. It's a different kind of like a thing which is not very important here. So here what you need to know, okay, when we talk about this kind of like this structure, so what will happen, that there is this, like you can see that in case of inhibition, substrate dependent. So in the given graph, if one side there is a substrate and one side there is a speed or rate of reaction. So if you remember from the beginning, here I told you enzyme they increase the speed of reaction. Okay, so if there is nothing, just a normal enzyme is putting, and there is some sort of reaction, so what will happen that when time increases, that enzyme, that substrate will form the product. Now at some point when whole enzymes are being used, they go to the saturation, this point. So at this point it is the Vmax, and when you have the Vmax by 2, at this level substrate concentration is known as Km. Okay, now in the graph, or here I forgot to tell you that enzymes, they are always less in number or very small amount. So what will happen that here in the given graph, in the beginning, suppose that you have the 100 molecules of the enzyme. So 100 molecules of the enzyme will be being used. So the first here rate will be directly proportional to the substrate, because enzymes like this one, like enzymes are proportional to the rate of reactions. At some point rate will not be proportional to the substrate, so that will be known as zero order reaction, and this one is the first order. Okay, so this is just a part, just a part, and where we can have this kind of graph, and this graph is hyperbolic. This graph is famous and many times it has been asked. This is the Michaelis Menten kinetics. Now Michaelis Menten kinetics, this is the absolute saturation, and this happened. Now if like here I told you that the 2 points here, that Vmax constant and Km value increases when substrate concentration is increased. So in competitive inhibitor, Vmax is like the maximum speed of a reaction is constant. So in this situation, when it is a competitive inhibition, so in competitive inhibition basically it will be like this way. And when there is a non-competitive inhibitor, okay, because you can see that Vmax is same, so it is a competitive inhibitor. Now when it is a non-competitive inhibitor, what will happen in this case? In case of non-competitive inhibitor, here Km is constant but Vmax decreases. So what does it mean? It means that the Km is constant and Vmax decrease. So this one is the non-competitive inhibition. Okay, but this one is a Michaelis-Menten curve. Michaelis-Menten kinetics of curve. What has been asked in the exam, that was a linear Weber plot, double reciprocal. It is something different. Okay, linear Weber plot is actually he made a linear equation. Okay, so sorry, it is line Weber plot. So he made one graphical representation. So in the given graphical representation, what he did, he made a graph, and here directly I am explaining you the graph and giving you the trick without wasting time to derivation, because derivation we never ask and it has been never asked as well. So in the Landwehr-Berg plot, this is a straight line, so a normal reaction is going on. So this is basically 1:s. Actually it is given in the question, 1:s and 1:v. This is the speed of reaction. Now in this graph, there is also non-competitive and competitive inhibition. Okay, competitive inhibition is basically here is a reversible one, or we can see the graph for the competitive inhibition is here. Competitive inhibitions, it's like this. And in case of non-competitive inhibition, the graph goes like this. So this one is competitive inhibition, and this is non-competitive inhibition, and this is normal or without inhibition. Without inhibition. This value, this is actually substrate concentration, so it is the Km, again the same as the previous one. Because it is a negative side, it is 1 by minus Km. And the point where the y-intercept occur, because it is a y-axis, it is it is x-axis, it is y-axis. So point at which the y they intercept, so this point is here, it is the Vmax by 2. So in case of competitive inhibition, you can see that Vmax is here constant, but Vmax changes in case of non-competitive inhibition. Now the trick in the USMLE first state, it has been given, so you can use this trick here also to solve this question, and it will be, believe me, it will be very easy for you, that competitive inhibition, they cross each other, and the second one, non-competitive inhibition, they do not cross. So you can see that in the given graph, competitive inhibition, it cross. Okay, next trick to remember, that there is a competitive inhibition increase Km. So there is a 2 time K and 2 time I. It is just a mnemonics to remember. So competitive inhibitions here, they basically here increase the Km value. So if you remember just the last 2 line of mnemonics, now coming back to the question, identify the type of inhibition given in the graph. So if you remember that mnemonics which I told you, competitive inhibitors cross, and non-competitive they do not cross. So because they do not cross, so it is a non-competitive inhibition, and out of which there is a it is not competitive inhibition. Now uncompetitive inhibition, it is a no inhibition itself, it is an uncompetitive. Allosteric inhibition is something else, where there is a inhibition of there is a substrate, or there is a binding of the allosteric site. So only this graph and this explanation is important for you. One thing more, if you want to just remember the name, or so here one more thing you can remember, there is an example of the competitive inhibitions and non-competitive inhibitions. So in case of competitive inhibitions, there is succinate dehydrogenase inhibited the malonate. So succinate dehydrogenase by malonate. Or in case of non-competitive inhibition, there is a pyruvate kinase by alanine. Okay, so hope this explanation will help you to solve this kind of questions in the future. Now we'll meet you to the next question. Thank you.